Hello students. In this lab session, we will learn the fifth program in the AI lab, that is using OpenCV Python library, capture an image and perform the following image processing operations. That is image resizing, changing the size of the image, blurring of the image, grayscaling of image, scaling and rotation, and the edge detection. All this you are going to perform using the functionalities that are available in Python library. So first what you are doing is, initially you will import the required libraries. From PIL, import image, image filter, and then you are importing OS, system library, operating system, that is to work with files, and then import CV2, that is nothing but the OpenCV Python library, and then you are importing matplotlib library, that is for plotting the graph or plotting the image in the program. These are the libraries you are importing. And then next what you are doing is, first thing is you are going to rotate the image. This is the code for image rotation. So open off, you are opening the image.jpg file, this image file, in opening it using the image of. This is the functionality which comes under this PIL, Python library, image.openOff. You opening the file. See, before that, if your Python file is, for example, stored under the folder program5, then the image, this is the image, img. Okay, this should be present in the same folder. This is your Python file, the program file, and this is the image. So this is the file you are importing it into this Python file. It is nothing but into your spider. Yeah. So you are copying it into IM, and then next what you are performing is, this is an object for this function. So using this object dot rotate off, calling the function rotate off, and you are rotating the image by 90 degrees, that is degrees counterclockwise, and then you are calling image dot show off, that is it will display the image. We'll go to the code here in the spider. See, this is the piece of code for rotating the image. Let us see after rotating the image. Now I will put the rest of the code in comment lines so that you can see the image being rotated. See comment lines, and then run the program. Now when you run the program, you can see that the image, rotated image, is being displayed. The image is being rotated by 90 degree. Next, I will just remove this comment line. The next 3 lines of code is for resizing the image. That is, you are going to size is equal to 128 in, 128. That is, you are resizing the image into 128 by 128 pixel. The size you are storing it into the variable size, and then im dot the same object, using this object you are calling the functionality resize of, and giving the size. This is nothing but the size 128 into 128. You are changing the size of the image and storing it into image1. Now here what happens, image1 dot save of image resized dot jpeg. After resizing, you are storing this image as image resized dot jpeg. That means in the file name of this image will be this one. It will be stored as a file in your folder. Let me check, run this. The rest of the code I'll put it as comment lines and run this piece of code. Both the piece of code. First one is image rotation. This is image rotation. Now in the folder, the second option, that is resizing. After resizing, it will be stored as image resized.jpg. We'll go to the folder and check whether it is present. Yes, you can see that this is image resized.jpg file. I'll just open this file. This is the resized image. You can see that the size has been changed. I'll close both these. Next, what you're doing is you're performing the blurring of the image. Next functionality. So for that, what you're doing, im dot filter of image filter dot blur. You are calling this module under PIL. Image filter dot blur. This is for blurring the image, and then blur image. You are storing it into the variable blur image, and then you are doing blur image dot show off. It will show the blurred image, and the same blur image dot save off. You are saving that particular image by the name blurring dot jpg. Now we'll put the rest of the code in comment line and check the output till here. After this line, what is the output? So when I run the code, this is the rotation, and then this is blurring of the image. See, dot show off will pop up this blurred image. This is your blurred image. As well as in blurring of the image, see here in this line, you are also saving this blurred image with the name blur image dot jpg. You go to the folder and check. You can see that image being saved here, blur image dot jpg file. You can open and see that image. Yeah, this is blurring the image, code for blurring the image. Next, what you're doing is, next again using the OpenCV, you are reading the image again, but you are passing an argument 0 here while using the imread. That is because this 0 argument means the image is to be read in grayscale mode. You are going to perform grayscaling here. So it will be read in grayscale mode, and it will be saved into image variable. Now using the OpenCV, you are calling im show of grayscale image comma image, and wait time you are giving it as 0, and then it should destroy all windows of the, so it will create the image, that is grayscale image. Let me put the rest of the code in a comment line. Now I'll run this program. This is rotation, this is blurring of the image, and then it will perform the grayscaling. See here, here the file has been popped up. This is the grayscaling. Click on this, you can see the grayscale image here, this one, and then you can close all these. Next, the last one, after grayscaling, what you are going to perform on the image is the edge detection. Edge detection, that is using an algorithm called canny edge. You are going to detect the edges of the image. That is, you are reading, initially you are reading the image using the OpenCV Python file imread underscore grayscale of. You are reading the grayscale image in the form of grayscale image and storing it in img, and then edges is equal to using OpenCV 2.canny. This algorithm, which is present inside the OpenCV Python file, you're calling it and giving the parameters image comma 100 comma 200 x-axis and y-axis values. It will be stored in edges, and then what you're doing, you are plotting it. You are going to plot this canny edge image. Plot dot subplot of this is from matplotlib library. You are using pyplot for plotting the image. So subplot of your plot dot image dot show of CMap is equal to gray. It will show the image, first image. That is, next what you are doing, plot dot title of, you are assigning the title, that is original image, plot x ticks and y ticks, x axis and y axis you are giving. And then one more subplot you are doing, that is the image dot show of the edge detection, grayscale edge image you are displaying, and giving the title for the same as edge image. And these are the x-axis and y-axis, and finally you are displaying the plot, that is plot dot show off. It should display the plot. Now let me run the program again. When you run the program, this is the rotation, blurring of the image, and then grayscaling. I'll just close all these, and then it will perform the canny edge detection, that is plot is being here in spider. When you go above your console, you have an option where you can see the variables and plots. You have the plots session here. Under this plots, you can see this graph, the canny edge detection image being plotted. See, this is the original image. Here you are giving the plot title. See, original image, and this is the another second one is the plot title you have given as image, edge image. This is your canny edge detection, edge image. Here the algorithm we used for this edge image detection is the canny edge detection algorithm. So hope you know how to, hope you understood what is this program and each part of the code, and how to execute the program and how to see the outputs. The same program along with the output, I will post it in the Google Classroom. Write the record and attend the session and mark your attendance. Thank you, students.